Okay. This particular piece is going to be about dealing with, what are the important things to know in terms of output. And we'll, start by looking at the example output, and then we'll run something else and kind of look at that. But what's important to know and kind of interpret a little bit better some of these notions, some of these ideas that we kind of dealt with before. So let me go over and grab that example. Okay, now let me pull it up so that we can, that's not it, okay. So I'm going to pull up that example 2 that you were looking at that has some variation from your output, and then we'll kind of come back to make some sense out of what's happening in that output file. So let me grab. Okay. So you should be seeing the example 2. Crunch that down a little bit better so we can expand this out just a touch. All right. Well, that's about all I can do there. All right. That second example, which I'm assuming you had a look at, but then discovered that you didn't particularly had some issues with that in terms of having some variations between the example and what you had up there. Now and this is the one sample, independent samples t-test. So we'll kind of start there, playing with it. And some things you always kind of want to get, and which I added some pieces in an addendum, in that you always accept the kind of the default test in most cases, unless I tell you differently. There is a mean difference idea, which is just basically that it is what it says. It says, what's the difference between the two means of the two groups, because there can only be two means. And I had you click effect size not on this example, but I think on the addendum, I said you can click on that. And then the descriptives piece, which gives you the means and standard deviations and that sort of stuff. Now, over on this side, and you'll find this in all of the settings now, you'll find hypothesis, particular hypothesis. And this is that one-tailed, two-tailed thing. The default one is always two-tailed rather, and that is the two groups are different from each other, or the two groups significantly different. And then then there's a one-tailed one going one direction, one-tailed one going another direction. And so you can always, make those things happen as you kind of go through them. And one thing I didn't have you do was this normality check, which is available, and we'll run that on some of this data in just a minute. As you get output, and I know some of your output looked a little different, and that's okay, because essentially all the meaningful pieces will be in either one. Now the first stop is always Let me see if I can grab something to mark that thing with. Where's that big arrow at? The first step, the first thing you look at is always the p-value. That is the significance level. Sometimes on some procedures, it'll just be called sig or significance. But it's the p-value, which is the probability. P stands for probability, but it also signifies, significance levels. Now, in this case, the p-value is 0.014, which means that you are there is less than a 1.4% chance, less than a 1.4% chance that you have reached this particular outcome as a false positive. And our cut score is always less than a 5% chance. So there's only about a 1.4% chance that if you say these two things are different, that you will be wrong, that you will have endorsed a false positive. And our guide, our standard is a 5%, less than 5% chance of a false positive. And so this is a significant outcome. These two samples, these two groups, which was done by gender, one was male, two was female. I don't think I gave you that code book information. The difference between the two means is minus 4.94, which is 1 minus 2. And if you go down here and you just do the math here real quickly, between the two means, you'll get the same thing, 4.94 minus 4.94. These upper and lower are really not terribly meaningful notions. It simply says that, our belief that we have a false positive is somewhere between these two things. Well, you don't need to really worry about that confidence interval because it's a meaningless one in this regard, because we're talking about mean differences between group means. And so it's not a real meaningful thing. What you have down here in the descriptives is for each of the groups, the N, the number of folks, the mean score, GPA wise. For males, it was 2.56. For females, it was 3.05. The standard deviation is what defines those divisions on a normal distribution. And so if I said, what represents the middle 95% for this group, for this distribution, the answer would be somewhere between a score of 2.59 plus 2 times the standard deviation on the high side, and 2.59 minus 2 times the standard deviation on the low side. Now, let me grab those numbers and let's look at that real quickly. I'm going to stop the share and pop up the whiteboard thing. range. So you should have the whiteboard up. Now, let me get stuff moved around here just a little bit. So if the two groups, if I said for group one, what defines the middle 95%? Or the area of random chance and so that's what we're doing. Group one's mean is 2.56. The standard deviation is 0.067 or 0.607. And so if I went up 2 standard deviations, it's 1.21. So this would then become, if I go up 2.56 plus 1.21, becomes 3.77. If I go down 2 standard deviations, then the GPA value is 1.21 from 2.56. So it's 1.35. And so the 95% middle range would fall between those two. And if it was the middle 68%, that would be 1 standard deviation down, 1 standard deviation up. Now, that is different from minimums and maximums. Minimums and maximums are just the lowest score and the highest score. But that's, normally given as part of the descriptives too. And so if you want to know where the critical values are for this distribution, the critical values above and below which things are significant is 1.35 and 3.77. So if we thought real quickly about a little normal distribution, and the mean 1, 2 standard deviations, the mean 1, 2 standard deviations. The point at which this 95% range would fall is 1.35 on the low side and 3.77 on the high side. Okay, let's get out of this little share. So what we're actually saying with that output then is males are significantly higher or significantly dumber, I guess. Males have a significantly lower GPA than females in this sampling. Or we could say that females have a significantly higher GPA than males in this sampling. Or we could simply say males and females are significantly different on GPAs. And all 3 of those would be reasonable outcomes from this data. Any questions about that?
I have a question.
Sure, go ahead.
So we could tell that they were significantly different because of that p-value. Is that right?
Because of the p-value.
Okay.
Yeah. It's always either the p-value or the sig level. You know, sometimes they'll, some routines will say significance and they'll shorten it to sig. But it'll be one of those two things generally speaking, p or sig.
So you said the standard p-value is 5%?
0.05. 5%, 0.05. So anything below 0.05 is going to be significant.
Sir?
Yeah, go ahead.
So the critical values you mentioned, are those representing the boundary of that 95%? So anything that's outside, you know, on the left side, to the left of that 1 point something value, and then to the right?
Exactly, yes.
Okay.
Yeah, yeah, they represent the boundaries of the 95%.
Okay, thank you.
And so anything above or below that is significant. Okay. All right. The next example was this dependent T or paired T test, pre-post, whatever you want to call it. You'll see all those names pop up from here to there. Sometimes pre-post they'll use, there's another procedure that can be used. It's called a repeated measures analysis of variance, and we'll talk about that when we get to ANOVA. But generally speaking, if you have pre-test and post-test, you would use this t-test, paired t-test option. Once again, it is students. We could have checked mean difference and effect size, but we didn't. Descriptives are in there. And once again, this is a two-tailed test and not a one-tailed test. And so when we run that, pre and post, T, degrees of freedom 38, the p-value, now when the p-value gets very, very small, they generally will indicate that by less than 0.001, which means you're about 99 point whatever sure that if you say these two things are different, that's not going to be a false positive. And so, well, to say another way, you're 99% sure that that's not a false positive when you say there is significant difference between pre and post. Or you could turn it around the other way and say, you know, you're less than 1% chance of this being a false positive. And you'll see it mentioned both ways. Whichever way makes the most sense to you is fine. So that means they are significant. The pre-test was significantly lower than the post-test by about 8 points. And, you know, once again, the boundary here for the two-tailed test would be 66.03 minus about 17, 66.03 plus about 17. So that would be what, 59, 49 on the low side, about 49 on the low side, and about 93 on the high side. Now, a quick way to talk about one-tailed test is just to divide the p-value in half. And so on this, it wouldn't matter because it's so low that if you talked about one tail, two tail, it's probably all going to turn out the same. But it could happen that sometimes you have a two-tailed analysis that's not significant. But when you divide the p-value or run it as one tail, you discover it is. And so it's a matter of whether you're asking a directional question or a, you know, omnidirectional question. And then the one, you know, the one sample is just basically it's like an independent sample, except we know what the one value is. And we're using like a population parameter. Now, oh, I want to go back to the paired for 1 second. Up here, we're not talking about differences between you know, two different groups. We're talking about differences pre and post in one group. And so we always want to interpret that in terms of what we're supposed to accomplish, what we're trying to accomplish in this experimental setting, or learn from this experimental data. If we want to know, you know, was there a decreased blood pressure from pre to post, we'd have a high blood pressure probably at the beginning and a low blood pressure at the post. So when we did, you know, pre minus post, we get a positive outcome. If we're doing something else, you know, like this GPA and comparing males and females, you know, we have a negative outcome because the way the formula works, on the top of that formula is what's called is pre-post. That's the comparative value on the top of that formula, pre-post, pre minus post. And so if the pre is higher than the post, then you would expect a negative outcome. And so the sign tells you the direction of the outcome, but it doesn't, you have to figure out how that comports with the outcome direction that you're hoping. And the scale, you know, what's the value of the scale? Does the scale go up as it gets better, or does it go down as it gets better? And so in interpreted paired samples, you really have to know a lot about the instrument, a lot about the scale and all that to make really any sense out of it. This will only tell you if it's significant and in what direction, and it won't necessarily tell you whether that means anything or not. With this one sample, it's a sample compared to an overall population, not a sample to a sample. It's like comparing a sample mean to the population mean that's in the center of the distribution, except you set that mean at the center of the distribution. And in this case, we set that mean at 950. We made 950 the center of the distribution. And so we wanted to know, is this value from this group significantly different from the population? And so when we go look at it, yes, it is. P-value is less than 0.05. So therefore, this group is significantly different from the population. And the way in which you go to test that, or the way in which you go to interpret it, you compare the mean that you gave, the mean that, the mean that you derive from your sample against the given mean of the group, which was this 950. And so we can say that this particular sample was scored significantly higher on SATs than did the population average. But you set the center of the distribution by this population average. And so those t-test works for a lot of things. And it only has to have, one sort of given, in that you have to have a categorical, no more than 2 categories, independent variable, cause and effect. Independent variable would be the cause variable. And you have to have a continuous or a quantitative outcome variable, which in this case was SAT. Oh, excuse me. Okay. Any questions about the t-test piece?
No, sir.
Nope. All right. Just one or two little pieces leading up to the next piece, which is going to be analysis variance, which I'm going to do in a full video. So I'm not going to try to talk about that this evening. Okay. Oh no, where'd nothing go? Okay. I've got 6,000 screens here, so I'm trying to get rid of a couple. All right. Just in talking about the t-test pieces, when you're doing any sort of t-test, you can have the end can be anything, but it should be balanced. And so let's say you have 2 groups. The n of group 1 should be relatively equal to the n of group 2. So, if one's 18 and the other is 20, or if one is, say, 25 and the other one's 30 or something like that, you're okay. But if one of them is 15 and the other one is 50, then you will have issues in terms of perhaps some error, and the error could be non-detectable because it could be error that you really can't look for, because it's primarily related to the way the statistic is calculated. And so you can have, the number of groups is no more than 2. Groups have to be less than or equal to 2. You can't do more than 2 groups. And so let's say that you have 4 groups. 4 dosages that you want. In fact, the example I'll use in ANOVA is 4 dosages. Let's say you have 4 doses. If you were to make all the comparisons between 4 doses, that would be 6 different comparisons. Between 4 groups. And you can do the counting yourself. You can do A, B, C, D, and figure out all the unique 2s there, and you'll get 6. So there's only 6. There's up to 6 comparisons in 4 groups. If you are limited to no more than 2 groups to a comparison. If you think about it, each one of those groups, each one of those comparisons, you are testing at a p-value of less than 0.05 per comparison. And so if you do 6 comparisons, then by the time you do 6 comparisons, the summative p-value is now less than 0.30, because it would be 0.05 for each one of those comparisons. And so with the summative p-value being 0.30, that means there's a 30% chance of a false positive, and that's just, quite frankly, way too great. Now, we have to always protect against false positives, because that, you know, that could be a really bad error to make. In those cases, the worst error to make. And so we're at, you know, 0.30. And so we can't do this. Not good. So what do? We do what's called analysis of variance. More than 2 groups, we do what's called analysis of variance, or ANOVA, and that'll be the next video. Because not only does ANOVA allow us to do more than 2 groups, it allows us to do more than 1 independent variable or multiple dependent variables. Now, we won't get all into that in this course, but it does allow you to do a much more complex and a much more involved analysis, all under 1 error rate, which is 0.05. Because you're doing 1 test, and so the error rate stays at 0.05 for all the different possible comparisons in there, because you're doing them all at once, all at the same time. And so the video that I'll do on ANOVA we'll spend a little bit of time on the really the sort of the theoretical base of it, the logical base of it, but it will also spend some time in looking at an actual couple of ANOVA examples from a new data set that I'm going to introduce to you this evening, but that we will use for ANOVA and some other stuff. So that's where we're going with stuff. And let me see if I can pull that data set up. Okay, I'm going to share up a little thing off of As You Learn, and then I'm going to open this new data set so you can see what it looks like before you go in and start playing around with it. So let me go grab that up. Okay. This is the data set that I will be doing some stuff with. And in fact, this is a particular cut of a data set that we'll be using all the way through the final exam component. Now, this is a data set that's done on an NIH site, National Institute of Health site. And it's of a survey that they give on an annual basis to a random sampling around different parts of the country. And so they enter a new database every year. This one's 15, 20 years old. But you can go on NIH and find a similar database site. And this one gets at a lot of habits, life habits and eating habits and smoking habits and drinking habits and all that sort of stuff. And I'll show you the data in a minute, but some of the variables in there are, what was the age you first smoked a cigarette? What was the age that you started smoking every day? Number of days you've had one or more drinks in the past 30 days. I imagine the pandemic has bumped that up just a touch. Ever arrested or booked for breaking the law? Your height in inches without shoes, weight in pounds. Have you ever been told you had cancer? Have you ever been told you had high blood pressure? What's your body mass index? Sexual identity, broken into 3 broad categories: sexual gender, male, female, marital status, educational history, the age, the age of the respondent, and then your overall health record. Have family members ever received food stamp, total family income, and then what type of area did you grow up in? A metro, or large metro, small metro, or non-metro? And so those are all, bits and pieces of data. This is up on As You Learn that will be in that database. And let me pop that up quickly. Okay. If I can remember where I put it. If I can remember where I put it. Over there. All right. Voila, got it. Okay, bingo. Took a little while to get here. So this is what this new data set looks like in JASP. And it's called Example 3 Advanced. And so you'll find it as a CSV file, and so you'll have to load it into JASP. And it does have some ever had cancer or high blood pressure or booked. There are some in here that are binary independent variables, and then there's a lot of things here like age and BMI and stuff like that. Weight in pounds, height in inches, that can be continuous variables, and so we'll use it for several examples now as we go forward. So, feel free to go along and kind of play in that if you want to. I did want to cover. No, I won't. I'll stop right there because if I do, I'll open a whole nother can of worms, and So when you get the ANOVA video up, you'll also, I'll open up the next block of activities, which will involve doing several small versions of the analysis using different techniques, different approaches. And I'm telling you, the hint is you have to use so-and-so here and that sort of thing. And so it will be one that you can kind of work with a little bit and look at, kind of play with the example. And then by the 1st of next week, I'll have the, I'll be gone. So by the 1st of next week, sometime over this weekend, I'll have the next whole block of assignments up that you can work with until I get back. And then 2 weeks from now, we'll kind of shift gears into the first quote unquote real evaluation. So now it's starting to look like a stats course. And from here, it's pretty much you. And asking what questions you need to ask. And, we'll try to answer as many as possible and try to get you where you kind of need to go with some of this stuff. And hopefully by the time we all finish in about 6 weeks, 5-6 weeks, you'll be where you need to be, and I'll feel good about that. Any other questions or thoughts?
The assignments that you sent to us next week, sir, will there be answers included so we know whether we're doing it correctly?
There'll be a
compare outputs.
sheet. Yeah, there'll be an answer sheet.
Okay.
Yeah.
Thank you.
But you might, always try to run them before you look at the answer.
Oh, of course.
Because that would, that kind of defeats the purpose. But the idea is that the only way you really learn these things, you just work with them. You just do them. And you develop a certain level of comfort with it after a while, and you just, you don't really notice it that much anymore. And then you wonder, why would they pay somebody to actually teach you that? Because it's such common sense stuff. But what can I say? They have to do something. They have to have something for the old guy to do. You can't, got to keep you busy or you get in mischief. Start writing things they don't want you to write about and stuff like that. So, all right, folks. All right, I'm going to kill this recorder